Hello, my name is Suder, and as part of the International Engineering Field Experience class I took this semester, our goal was to address one of the 7 Millennium Development Goals of the United Nations. And to solve this issue, I chose to design a process called a solar water distiller. So the Millennium Development Goals for 2015, there were 7 of them, and the goal I chose was Goal 7. It is to ensure environmental stability, and the specific target I chose was to have by 2015 the proportion of the population without sustainable access to safe drinking water and basic sanitation. Some of the current technologies that exist to address this issue are UV light point-of-use systems, sand filtration systems, drilling wells, and then there are also devices called a water cone and a solar ball that are specific to water distillation. So, as the problem said, the goal was to have by 2015 the proportion without access to sustainable drinking water, and this video addresses some of the reasons why it's so important.
Safe water and sanitation are critical. Without them, life is in crisis. Today, 884 million people have no clean water. 2.6 billion people have nowhere to go to the toilet. Half the hospital beds in developing countries are filled with people suffering from diarrhea caused by dirty water and poor sanitation. Diarrhea is the biggest child killer in Africa. Worldwide, it kills 4,000 children every day, more than AIDS, malaria, and measles combined. 443 million school days are lost every year due to water and sanitation-related diseases. Millions of children waste countless hours collecting dirty water from distant sources. And if schools lack decent private toilets, teenage girls often drop out altogether. This crisis makes progress impossible, and yet there's a huge shortfall in funding. In 1990, 8% of aid was allocated to water and sanitation. By 2009, that had shrunk to just 5.5%. Governments across Africa recently agreed to spend 0.5% of GDP on sanitation. In almost all cases, this promise has not been met. In April 2012, world leaders will meet in Washington to talk about water and sanitation. We need to tell them, water works. Taps and toilets save lives. They are cheap, simple, and effective. For every $1 you invest in water and sanitation, on average $8 is returned in better health and increased productivity. That's people well enough to earn a living. That's children carrying satchels instead of jerry cans. That's teenage girls attending schools with decent private toilets. Every day, up to 4,000 children's lives could be saved. All governments can do more to solve the water and sanitation crisis. So please, take 1 minute to tell world leaders water works. Take action now. Go to wateraid.org/waterworks.
So as you can see, water is globally becoming a crisis, and as time goes on, it's just going to be even more prevalent. So some of the solutions proposed normally, in the United States, we have a centralized system which actually works from one center and distributes water to multiple homes. But in a developing country, something like that isn't as optimal because not only are people more remote, but the ground is harder, the water table is not as deep. There are so many problems that you run into that it's just not the best solution. And normally the initial cost of a centralized system will be higher and a decentralized system will be lower. So for Honduras, which is the selected country I chose to focus on, the problems with the water there are that the deforestation has led to a lower water table, as well as women and children having to walk up to 6 hours just to fetch water every day. Some of the current research and development started back in Honduras in 2004, and you can see the different initiatives and investments that companies and organizations have made, and it goes up until 2009, and there's still funding and investments going on. But like it said in that video, that for every dollar you invest, $8 will be returned due to productivity. So the objectives of my proposed solution are to focus on the production process, because there are other solutions to this problem, but the issue is that there's not a locally produced product, so they have to order it in, which increases the cost, and it's not always the most sustainable solution after shipping and everything like that. So if you have a locally produced product, it's going to be more sustainable in the long run. And the other goals of this product are to provide safe drinking water to Honduras and to design a sustainable and viable solution. For my design constraints, I chose to look at the water cone and the solar ball, and I chose to look at the best features of each of these while also looking at the environmental, economic, societal, and technical sustainability categories and grouping my constraints based on those. So looking at recyclability, the existing products are 100% recyclable, so I knew that designing my product, I knew that I needed to reach at least 100% recyclability, as well as the unit cost of the device. Focusing on the production process would decrease the cost, but it's really important to make sure that a new solution is more affordable than existing solutions, or else you might as well go with the old solution. So the existing solutions offer anywhere from 1.5 liters a day of safe drinking water to 3 liters a day. So my target for this was about 2 liters a day, as well as the evaporation level for any water and solution using these types of devices and water distillation would be about 8.8 liters per meter squared. And the weight definitely needed to be portable and lightweight, so you could transfer it and just have a decentralized system that you could move and have multiple. Evaluation of my product using these constraints were some economic, environmental, societal, and technical indicators of initial cost, user cost, recyclability, lifetime of the product, aesthetics, alternative uses, weight, diameter, and daily volume, and I based these off of the existing constraints from the other products. So these are my units of measure that I used. And from those indicators, I ranked these devices that already existed based on a scale of 0 to 3, with 3 being the most optimal choice. And as you can see, if 3 is the most optimal, then the plot with the most area covered would be the better decision and the better product. So as you can see here, the solar ball is the best solution. And for an example of how I would rank it, it would be that if the cost of the solar ball is higher than the cost of the water cone, it would have a lower score, so you would see it closer to the center of the spider plot. So for my solution, I decided to run my product and test it and build it, so I have a video to show you what I did.
My name is Suder, and I'm going to show you how to make a solar water distiller and how it works. So some things you're going to need. You're going to need your main dish, a collection dish, some spare change, a 4 milliliter beaker, some iodized salt, a scale, and then some cellophane, which the goal of this project is to make over. So to make the salt water concentration, the average concentration is 35 grams of salt per liter of water. So we're going to have a 250 milliliter sample of water that we're going to use in this experiment. So you're going to place your collecting dish on the scale, and then zero the scale, and get 8.75 grams of salt in your collecting dish. And then you're going to take the salt and put it into your beaker and fill your beaker up to the 250 milliliter line. So now you have your whole water distiller built. You have your outer tray, you have your collecting dish, you have your saltwater solution filled around in the bottom, and you place some change on top to make sure that this all will come in towards your collection dish. So you go and set your system out in the sun, in the heat for about a day, and throughout the day, as the heat evaporates the water, the droplets will form onto the cellophane and the water should collect and condense and fall into your collection dish. So once you've left your dish out in the sun for about a day, you can come back and take off your cellophane lid, and you should have the water stuck in your collection dish, and then here you should see whatever you have removed from your solution left in your outer dish. And now you should have some safe drinking water right here in the middle, which you can repeat the experiment with some dirty water or some sticks in the water or anything else you want to see if you can remove it using this process. And that's how you can make your own solar water distiller at home.
So as part of this solution, I decided to go with cellophane because after looking at other plastics and looking at the environmental effects, you could tell that cellophane was a better solution. There is some research into plastics made from plantain flour, but it still has a long way to go before it's able to be used. And the cellophane is biodegradable, and you can just put it out with your compost after using it. So the cost associated with this product would just be for the original roll of cellophane or the lid that you're going to make, because the purpose of this product is to be able to use dishes that the family would already have in their home. So you would use 2 of the dishes you already have, and then you would just buy some cellophane that's been produced locally and place a lid over top. And this lid would last for about a month until you would need to replace the lid again, and then you could just put it out in your compost. So the operational cost would just be around $6 a year after buying about 2 rolls of the cellophane. As I said, operation maintenance for this product would be very easy. You wouldn't need a high education level. It would just be making the system and then setting it out into the sun and removing your water and refilling the system while cleaning it. So all you would need to do is pull back the cellophane lid and take out the collection dish and clean the holding dish and then replace the lid. Or whenever the cellophane was starting to degrade, you would just remove the lid and put a new lid over top. In conclusion, Honduras can convert its large amount of the undrinkable water that they have access to in the ocean into safe drinkable water using a solar water distiller. And the system can be produced locally at home using their own dishes and products they already have, and then producing some locally made cellophane. And the system will be reusable and biodegradable. And that's all I have.